Hello friends, today is I am going to discuss something new like trees and networks. Hello friends, I am Manibhushan. Now today I am going to discuss one of the most important topics, trees and networks. So let's see just today. First, try to understand. Most of the time we will see the networks are object that contains nodes and edges between the pair of nodes, and they can be used to present a wide variety of real world situations. So such as distributions and scheduling. Mathematically, networks are useful for visualizing combinational problems and make for a rich and fascinating theory. So there are of course several different kinds of networks. We will mostly deal with the simple networks where edges connect two distinct nodes. There is at most one edge between any two nodes, and all the edges are bidirectional. So a tree is a special kinds of network in which there are no cycles. That is, there are no list of nodes in which each node is connected to the following node by an edge, and the final node is connected to the first. Similarly, the trees are especially the simple inner term of their theory because they connect the numbers of nodes which the fewest possible edges. A complete network is network in which every node is connected every other nodes by edges. So I will try to the creating a networks in Python's visualize networks, and we try to understand like the basic characteristics of network. And if I have gotten a time like then I can generating the adjacency matrices for a network, create a directed and wedges networks, and also we will try to the finding the shortest path in a networks. Okay, and try to the some discuss clusterings of network and coloring of a networks. So let's see the some technical requirement here. So we need to the import like a import import network work net would work as nx. Let's add nx. So let's see. I think needs to import the pip. Otherwise, network x as a nx. So just I am going to the import, and is it working and not working? So yeah, it's working. There is no need to the install. So it has inbuilt. Don't worry. And after this, creating a network in the Python. So this is a network package. So import network as a nx. And now first step, create a Python representations of a simple graph. So we need to create a graph object. So we'll store the nodes and edges that constitutes a graph. So I'm going to write here like a sum g as a graph, and will equal to nx dot graph and parenthesis, right? And let's see here, is it working and not working? So no, I have got an syntax error. So what is this? Okay, sorry, I did write here the nx dot graphs, not this one, because nx here dot graphs. So now you have gotten here. Now I want to add something like G, capital G as a variable, and dot add something like I want to the add underscore node. So let's see, we can add like add edges for from, add node, add nodes underscore from, add weighted underscore edges underscore from. So add node and create one right here. So we need to add the nodes for a network using the add nodes methods, and similarly I can, if I want to add the like two nodes, so I can write here, and we can write here like a two here, right? See, so if you want to to avoid calling to this method repeatedly, so we can use the add underscore nodes from method. So if I want to like here we can add, and here we can avoid a calling method repeatedly, so we can use like this G dot add G dot add underscore edges, yeah, nodes from this one bracket start, right? A square bracket. You can write here 3 comma 4 comma 5 comma 6, right? So G added nodes underscore from. Why do I use? Because I want to avoid calling these methods. So let's see, the next we need to add edges between the nodes, and we have added using either add underscore edges methods or add edges from methods also. So let's see here. After that I am going to write here capital G, I have already created, dot add underscore edge and 1 comma 2 right here. And now need here, right here, age from 1 to 2, from 1 to 2, right? And second, just let's see, it has been added. And similarly, if you go like here, G dot add underscore edges underscore from and this one like a bracket, and we can use like a coordinate 2 comma 3, 3 comma 4, 3 comma 5, 3 comma 6, 4 comma 5, and 5 comma 6. 5 comma 6, and let's see here, it has been created. So finally we retrieve or view the current nodes and edges in a graph by assessing the nodes and edges attributes. So print here, just I am going to write here print and G nodes, like a capital G dot nodes. Let's see, could we print here like this? Similarly, if I want to write here like a print dot G edges, print dot G dot edges, and parenthesis. Okay, sorry for that. I think print dot G and edges like this, and you could see it has been printed like this, like a list and inside of the coordinates. So I think we have already. Let's see how it works. So the NetworkX package added the several classes and routines for creating, manipulating and analyzing a networks using a Pythons. So the graph class is the most basic class for representing network that do not contain multiple edges between any given nodes, and where their edges are undirected, bidirectional, you can also say here. So once the blank graph object has been created, we can edit the new nodes and edges using the method described in this receipt. So in this receipt we created a nodes and that hold integers value. However, a node can hold any hashable Python's object except NONE, none. So moreover, associated data can be added to the nodes, like where keywords arguments passes to the added underscore nodes methods also, and add underscore nodes underscore froms, just you can attributes we can also add it you when the using like this method by supplying a list and tuples containing the nodes objects and dictionary and of attributes also. So let's see, the first graph class represent the simple network, and which are the networks in are the joined by the at the most one edges, and the edges are not directed. So we will discuss directed network in the creating directed and weighted network receipts. So there are separate class for representing a network in which there can be multiple edges between a pair of nodes called multigraphs. So all of the networks type allow the like a self loops and which are the sometimes not allowed in a simple network. In the literatures, where a simple network typically refer to undirected network with no self loop. So let's see, and we can try to the visualize. So there is some technical requirement. We will also need to the matplotlib package. So first I want to import matplotlib.pyplot. I have already discussed details. If you don't know the word how to apply like a matplotlib, so import matplotlib lib dot yeah, and I have imported this one. So first we create the simple example like a network I have already plotted. So let's try. I can so G I did write like a G dot, I can write again like a G will equal to nx dot graph nx dot graph functions and parenthesis, and after that I am going to write edit something like a G dot add underscore nodes underscore nodes from, and taking a range like this, range from 1 to 7, 1 comma 7. So let's see, is it working or not working? Yeah, it's working. This means it works. Now I am going to create here like this one, and we will plot here. So g dot add underscore edges underscore g dot nodes underscore edges from edges from edges from parentheses and square brackets, and I can write here like just you can go here, and inside this bracket we need to the write here the coordinate 1 comma 2 2 comma 3, just I have written here 1 comma 2 2 comma 3 3 comma 4 5 comma. So let's see here, I am copying and paste because I have already created, so it's good to copy and paste. Put here comma and then copy and paste. So I have created like 1 comma 2 2 comma 3 3 comma 4 4 3 comma 4 3 comma 5 3 comma 6 4 comma 5 and 5 comma 6, and now close here. So let's see here, yeah, it has been created. So next we create a new matplotlib like a figure. So I need to create a figure, so need to the like a fig fig comma ax will equal to plt dot subplots dot subplots and parentheses. Let's see. So I have created. So we can create a layout that will be used to position the nodes on the figure. So for this figure, we shall use a cell layout using a cell underscore layout routine. This is your cell. But in this cell, so layout, so now we can create a layout that will use a position the nodes on the figure. So let's see, just layout out will equal to nx dot shell underscore layout. Did I get? Yeah. And we can put here the variable just I have taken here g. So let's see what happens just if I have create this layout like this. Okay, so this is the layout. I think you could see here it has been plotted like a 0 and from. This is your layout. So could you see the difference between like without layout you can see your figure like this, and I am putting here the layout like G. Okay, so 0 2 4 6 8 and 10. Here is also 0 2 4 6 8 10. Right, it's clear. So I hope now I want to the draw. So we can use a draw routine to draw the network on the figure. So since we have already created a matplotlib figure and axis, so we will supply the ax keyword argument, and we will also add a label to the nodes using width underscore labels. So let's see, nx dot draw, sorry for nx is not a nx dot draw and capital G, ax will equal to ax pos will equal to layout and like a layout with underscore labels with underscore lab labels will equal to, you can write it true, right? Let's see what happened. Just we want to draw G as a label like this. So G ax will equal to ax. I have taken a figure subplots and POS like a positions layout and with the label with underscore labels true. So you could see this is your figure. But if you want to set something like a G ax POS as a layout and with labels, but if you write here like this, ax dot set underscore title underscore alpha underscore sets underscore ti underscore title, and I want to put here name of this title like a simple network drawing. Simple network work drawing, right? Simple network drawing. So let's see here. I have already created here like a simple network drawing. So it's clear. So how to draw 1 2 3 4 5. It's a so a drawing of a simple network arranged using a cell layout. Arrange using a cell layout. So let's see, the draw routine is a specialized plotting routine specifically for drawing networks. So the layouts we created specifies the coordinates at which each of the nodes will be placed. So we use a cell layout which arranges the nodes in a concentric circle arrangement, which is determined by the nodes and edges of the network. So by default the draw routine creates a randomized layout. So let's see, just I try to getting the basic characteristics of the network have a various basic characteristics beyond the number of nodes and edges that are useful for analyzing a graph. For example, the degree of a node is the number of edges that starts at that node. A higher degree indicates that the node is a better connected to the rest of the network. So as usual, just if I can plot like a range, something you can create a more like a other nodes, like look here. So these step like a various basic some characteristics. So let's see, I will try to create a range like this. Import, copy and paste. So I could save my time, and you can see like this. So G will equal to nx dot graphs and add nodes from a range like a, I could write here not a 1 to 10, you will write automatically, you will take a 10, and edges from it will start like I can start one more. One, 0, 1, 1, 2, 2, 3, 2, 4, 2, 3, comma 2, 4, comma 2, 5, 5 comma 3 4 comma 4 5 comma 4 5 comma 6 7 5 comma 6 7 comma 6 8 6 comma 8 6 comma 9 9 6 comma 9 7 comma 8 7 comma 8 and 8 comma 9 9. So let's see, just I have created this one. Now the next, it is the good practice to draw the network and arrange the nodes in a circular layout. So we have already created a layout before, so I want to copy and paste this layout, and because I want to save my time here, but I will change something like this one, V, and subplots as it is same, and we can annex draw like C. So there is no need to the put here the draw. Okay, so you remove this one, this cell like this, and nx dot draw, it's clear, and but I want to draw like a circular, so in it draw like a circular, so underscore circular g ax will equal to ax, and with a label true, shouldn't not with a label true. So go ahead, label true, and now they set the sample network. Simple network. Let's see. And now I have plotted like this. So this is like it is a good practice to draw the network and arrange the nodes in a circular layout. So you could see here is so the resulting plot can be seen in the following figure. So as we can see, the network is split into the two distinct parts. So simple network draw in the circular arrangement, and there are the two distinct components visible in this network. Next, if you can use like a nx dot information, so you can get here some informations. How do we get the informations? So need to get here, like if you want to get information, so I have discussed most of the time. So print, and right here nx dot info and g, like this. So you could see here like graph with the 10 nodes and 12 edges, 10 nodes 12 edges, and it's you can see like this. So I hope you are comfortable and we can use. So if you want to use like a different property, we use the degree properties for of the graphs object to retrieve the degree of the specific nodes. So we need to apply their loops. So how to use a loops? So let's try like for loops. For I in list create here 0 to 7 here, you will start from the 0 comma 2 and comma 7, and after this here this one slicing, and now after that we will try to the degree. D G R double E will equal to G dot degree and put here I like this, and I want to print like a print here print F. So you need to the double quotation for what it formatted here the degree of I and like a degree and put here like this. So let's see what happened. I think it and everything it's all right. So you could see here the degree 0 to 1, degree 2 to 4 and degree 7 to 2. So this is your output, you could see here, and we can get the connector components of the network using like the connected underscore components. So if I write here like a connect components will equal to list and nx dot connected underscore component connected underscore components and G, and print components and print components. Okay, so you could see here like this, it has been printed like the 0 1 2 3 4 5 and this one. So I hope now you are comfortable, and we compute like a density of a network using like a density routine, and which returns the float between the like a 0 to 1. This represents the proportions of edges emitting the node to the total number of possible edges at the nodes. So let's try. If I am going to write here density equal to like this nx dot density and put here capital G and now I am going to print and like this density, and you can write here density. So you could see like this your density look like 0.266, and finally we can determine whether a network is a planar, and meaning that the no two edges node to be drawn crossing one another. So by using a check planarity. So how do we check? Let's see, we could check here like is underscore planarity. I think you can't see here, is underscore p planar cam PLA, no, yeah, planar and comma underscore after comma give, I think we need to give some space, and this one, this will equal to nx dot check underscore planarity PL score planarity like a G. And you can write here print is planar and is planar, comma, and is underscore planar. Right, see, and let's see here. So it has been printed like this. So it's planar like a true. So let's see, it's is the way to create and how to create a density, is a planar, is a true. So generating the adjacency matrices for the network, I will try to discuss in the next time. So I'm creating a directed and weighted network also. So let's see, today I am complete this one, and I think it will be helpful for someone. Thank you very much.